Good to go, Chris?
You bet.
All right.
Next speaker is Chris Wiswell.
Try to unshare my screen.
He's a senior software test manager.
Oh, good.
And he's a former Cordev employee. He also worked at Institute for Disease Modeling and has just started a new, exciting, fun job, which I'm sure he'll mention during his talk. So this talk's going to be about testing testing the COVID-19 model. Is that right? Did I get it right?
You bet.
All right, over to you, Chris.
Great. So I'm going to go a little bit fast here, but I'm going to try to avoid too much jargon, and hopefully I'm going to tell you a story and y'all might learn something. So let's talk about how to test software without being a scientist. So first of all, we'll go into the backstory a little bit about me and sort of where I was as of this time last year. So I've been at the Institute for Disease Modeling since 2013. I've been a test manager there since about 2015. The Institute for Disease Modeling, our stock in trade, is running computational models, or simulations, if you will, of how infectious diseases spread through populations. Traditionally, we've worked on things in the rest of the world. So diseases like malaria, HIV, polio. You can see them on the slide and a few other things. So a little bit of typhoid, a little bit of tuberculosis. These were our bread and butter diseases. We published dozens of papers in really respected journals using our simulation software to help answer questions. To do that, we have our flagship model, which is called eMod. eMod is a richly configurable piece of software. It's C++ with tooling in Python that can be configured to do lots and lots of different things. And so we're one of the best institutions in the world at modeling disease transmission with one of the most powerful tools. Then, of course, COVID hits. So as it turns out, there's a lot of diseases that make the news. During the course of a normal year, lots of things will come across our news feeds, and I'll occasionally go and ask our modelers what they think of them. Most of the time, the answer is, well, that seems kind of bad, but it's probably not something we need to worry about. In November of last year, that story was very different. And the first reaction I got from somebody taking a look at data we were looking at was, yeah, this one looks really bad. And the sad part was, as it became clear that COVID-19 was going to be a problem we were going to need to tackle, not merely remotely, but in our own country, our best tool, our most powerful model, was not the tool ready to do it. There's a bunch of optimizations in the eMod model that make it really good for doing certain kinds of disease modeling, malaria and measles being sort of the ones it's most tuned for. But COVID-19 required some things that we weren't really well suited toward, like contact tracing and different forms of social isolation that weren't usually used in the other diseases we model. However, the good news is IDM is continually growing, and it recently brought in a new a new modeler with some powerful new tools. Enter QASig. So when I first approached QASig with the project of, I should probably test this if we're planning on writing papers based on this software, I was really clearly out of my comfort zone. So I was used to working with a model I'd been using for the last 7 years that ran in certain ways. We had all these engineering practices, and you can see on the slide here under the eMod column, things were strongly typed, things were well-defined, we understood the software, and we had several years of engineering expertise and process built around building and testing this model. On the QASig side, it was different. So a lot of things were done in ways I wasn't familiar with. So instead of writing a configuration file and having your model consume it, configuration was done in the code itself. That sounds a little esoteric, but go with me for a moment. The critical bit was, this is very much not like what I was used to doing, and I didn't have any of my infrastructure to rely on. When I finally approached the modeler and said, I'd like to start testing your model, from your professional point of view, where should I begin? The response was, I'm doing test-driven development, so you really don't need to test anything. Just give me some code coverage numbers. This was a little disappointing, and as a professional software tester, felt a little disheartening. But then it was time for a little collaboration and a little compromise. Running off the power of humility, I started by reaching out to the developer after fumbling around with a couple of attempts at writing automated test cases. And we came to some agreements about how I could test this in a reasonable way. The first agreement was that I could run the model the way the modeler wanted me to. is you see in the little bit of code there, running QASig is very simple. That's just a screen cap from the README, which you can see on the website. And it was only 4 lines of code to make a simulation run. So I could learn to run the model in the way the modeler did, not through the heavyweight regression harness I was used to. Secondly, I got an agreement from the modeler when I explained why this was important to me, for them to document the parameters of the model and what they did. He even went so far as to add, in some cases, here's the test I think you should create for this parameter. And in some cases, he was pretty close to what I would want to do in the first place. So that was great. And I learned to live with relative validation. I'll talk a little bit more about those parameters and relative validation on the next couple of slides. So firstly, let's take a look at one of the 2 anchor points we had here. By anchor point, I mean, I need a way for my worldview to map onto the way the modeler sees his worldview. So we can come to an agreement about which parts we want to test and how we want to go about this. This is his code. So these are some parameters from the model at the time. And you can see there, this is all Python code. And we got a little dictionary with entries. And the entry labeled letter N tells you how many people should be susceptible to coronavirus. This was something I could work with. And I could see for each parameter, there was a comment telling me a little bit about what the parameter did. And I could start thinking in terms of how would I go through the normal test workflow of validating that a parameter is honored. So I'd write some code of my own. And over here is my anchor point that maps to that, which are my unit test support classes. These, as you can see here, it's also a Python file. But what I'm doing is I'm just mapping a string that's meaningful to me to the strings that the model needed to know. So in the case of that parameter that is the letter N, I decided that a more valuable name was number agents. This is an agent-based model, which is a little bit of a term of art. Basically, that means in the simulation, we have code that represents each individual person rather than just counts of people. And I need to know how many of those there were. So I have a parameter for that. There's an interesting anecdote about that particular parameter. If I manage to finish in a reasonable amount of time, maybe I can tell you. So what did we do? Well, we created some tests. And here's how we divided things up. The tests that the modeler had already created when he said he'd done test-driven development, were of the, I run a script, it doesn't fail, and then I sort of squint at the graph for a while and nod and go, that looks about like what I thought it would do. And that was his way of testing the larger properties of the model. Does this disease arc look like I think Seattle would look like? Does this look like I think Addis Ababa would look like? And that was his area. My area was to make sure that the smaller features of the model, the individual parameters, were being honored in a way we would expect. And I'll talk about that relative validation here. So these were things that I would write myself using the unit test module. And if we consider something simple like the number of agents, for example, I could say, if I set the number of agents to 100, and then I check the output of the model and ask how many people were in the simulation at time step 0, it should tell me 100. Really straightforward. And then you can loop through several different values and make sure that they work correctly. That's more of an absolute validation. Relative in this case is what we call the turning the knobs kind of tests. As I increase the infectiousness of the disease we're simulating, does it transmit to more people in a shorter amount of time? Now, I can't tell you with any level of precision exactly how many people I would expect to be infected in the 30th day of an epidemic, but I can tell you that if I set the transmissibility to, say, a value like 3, then there should be more people than if I set it to a value like 1. And that's the sort of thing we do with the relative validation that allows me to make sure each of the parameters is being honored in the right way. The frameworky stuff here. So when I showed you the unit test support class, this is an example of that sort of thing. And I was really happy to see that some of the things I put into my framework ended up helping driving quality into the project. As the modeler was looking at my tests, at one point he asked me the question, why are you renaming all of my parameters? Why don't you just use the ones I had? My off-the-cuff answer was because letters are cheap and words are readable. But from my point of view, it was I wanted a single point of contact that he could be free to name his parameters whatever he wanted to. And I could make all my tests work by changing something in one place. So when the parameter n became the parameter population size, I changed one string on one line of code, and the dozens of tests that consume that parameter all worked the same way, and it was kind of cool. It also kept the actual test method smaller, so when I'm trying to share a test to someone else who might need to run it or read it later, the actual lines of code they needed to pay attention to became 10 to 12 lines and not 30 to 40 with a whole bunch of constants thrown in. Made it a little more readable. So what's the story? What's the real point I'm getting at here? When you're testing really specific software in a field that is not your own, and I'm not an epidemiologist, a virologist, an immunologist, or any of these things, you need to trust your SME to understand that part. The next thing you need to do is understand that you are a subject matter expert. You understand software and you understand how to test it, and you can apply your art and knowledge and skill to a very complex problem from a way that the researcher, or pardon me, the subject matter expert might not approach it in the same way. To do that, you need to find the anchors you can agree upon and use them. And I've got my totally rad MS Paint looking visualization for this. I hope you appreciate it. So from the researchers, in the researcher's mind are the requirements, what he believes the model ought to do and how it believes it ought to function. He codified those requirements in that parameters file where he documented what each of those parameters should do. I was able to consume that file and use my test design skill to create simulations that at the conclusion of the simulation, I could validate that that requirement was being met in the way I expected it to. Following the typical flow of a test case, you configure some software, you operate some software, you make some observations, and you evaluate those observations. All 4 steps were possible from the single parameter level. And at the meta level of, but is the model doing the thing we would expect it to? That's really out of my field. And I get to leave that to the subject matter expert who has a level of trust that each of the parameters is being honored, and I can have the level of trust in him that the scientific principles are being honored. There's a bunch of links to GitHub here. I'd be happy to share those with anyone who cares to see them. And with that, I think I got this within the 10.
You definitely did. Thank you, Chris.
Yeah. Done this before.
Yeah.
I was on my front porch practicing no more than 35 minutes ago. I can't see the question UI from here. So I'm going to turn off my slide share. And if there are any questions, I'd be happy to tackle one.
And if anybody wants to raise your hand, we can open up your microphone too. So just let us know.
Also, if I was being way esoteric, that's also okay. I could field them, whatever.
Oh.
Can you see those, or would you like me to read those? So
please read for me.
Yes. What was the antidote you were talking about?
The anecdote about N. As it turned out, I actually, I kind of already gave it, but let's give you the more detailed version, is the parameter N drove me bananas, because as a person who does code reviews, if someone who worked for me labeled a variable N, I would go through the roof is not the right term. I would send it back to them and ask them to name it something I understood. In this case, the modeler thought that N was a perfectly good name for the number of people in the population. And I went ahead and put it in my support layer that it should be number of agents equals N. What I discovered a little while later was several of the parameters that I had renamed in that way, those names I had picked ended up migrating into the actual operating code. When other modelers came to the model, N was not as intuitive to them. It could mean number of people in the simulation, number of people who start out infected, or even something like how infectious is the disease itself. So I was really happy to see that some of my intuition in my renaming layer was valuable to other people.
Great. Park, does that answer your question about what was the story about it? I'm gonna assume yes. Mike asks, how do you feel test-driven development works with typical teams, and does it help you to be successful, or does it impact your work negatively?
Great question. There's a part of me that would like to defer that to someone in development, but I develop tests, so it's worthwhile talking about it. I have found, in this particular case, the test-driven development was actually pretty valuable. So this particular researcher, who's also a very talented and gifted Python coder, very seldom checked in things that were outright broken. And the initial effort for writing your tests for your test-driven development may seem a little bit pedantic, but I think that taking that extra time and that extra framework there makes the resulting code come out so much better the first time around. There's an old joke about cutting down a tree in 1 hour. And the joke is you spend the first 30 minutes sharpening your axe. Test-driven development I view as that sort of exercise. It just makes you more efficient. So I'm a fan. It's initially a pain, but I think it has value.
Great. Anybody else out there? Okay, I think we're good.
Well, nice job, Chris.